in an integrated way.
If you knew the market share by mode of transport on a particular route.
Okay. For those of you who are not familiar with who NEC is, the NEC is the Japan-oriented company with the global reach, about the 30 billion US dollar sales, and 100,000 people globally. And we have about 115 years old history. So in short, we are old and relatively big, and with many people working in it. And then maybe for some of you, NEC is known as a telecom equipment vendors. But nowadays, we have expanded our scope, and particularly in what we call the social value creation areas, to develop the social solutions, including the public safety, transportation, logistics, education, healthcare, or the public government service. And to support all of those activities, we have developed our own technology in-house. In Colombia, we participate in the project like the Vive Digital to realize the project. So although I realize the title of this big session is the big data, as you may notice already for the past 2 days, there's a big rise of the IoT. Now every almost 2 years, the new buzzwords coming up. The cloud computing, the social networking, big data, and the hottest word at this moment is the IoT, the Internet of Things. But when the new words came up, the old one do not disappear. Actually, there are many dependency or complementarity or synergy among those. The previous speaker that mentioned many times, the big data depends on the cloud computing. Without the abundant processing powers and storage capacity, the big data analysis is not possible. Actually, what IoT does to big data is to expand the scope of big data activity to include the real-world data on real-time basis. At the very beginning, the big data is for the data analysis inside the computers, like financial data. But with the IoT, now it can include the activity in the society, once again, in a real-time basis. So that will widely broaden the scope of big data by the combination with IoT. And the IoT-related business could be huge in several years. Some analysts says it could be $7 trillion market, not the $7 billion market, $7 trillion market in several years. But when we talk about the IoT, everybody thinks different things. So I'd like to introduce my way of segmentation of the IoT. I categorize the IoT in 3 parts. The first one is what I call the industry IoT. It is, in short, a big boy game. Means the heavy-duty machinery manufacturer, such as the Komatsu or the GE or Caterpillar, or those people have a very good reason to monitor the status of their products throughout the world. And actually, it is based on their own idea to become the service provider rather than the box seller. So instead of selling out the hardware, they intend to become the jet engine as a service type provider. Second type of IoT is what I call the consumer IoT, or personal IoT or user IoT. It could be the wearables, or it could be the smart refrigerator, smart washing machine, smart anything at your home. My categorization are primarily based on the business model. Industry IoT is driven by the manufacturers. They spend their own money to improve their own service, eventually to improve their profit margin. Consumer IoT, actually the consumer pays the hardware, software, and even for the internet connectivity. I would say the vehicle, the connected cars, they could be in between those two models. Car manufacturer has a very good reason to monitor the status of their products, very similar to the industry IoT case. But at the same time, they are so clever. By adding some premium service on top, they let their customers pay those investments. Okay, the last category is what we call the urban IoT. It could be the government IoT, local IoT, national IoT, or smart city per se. Actually, this is the picture I use all the time when I describe the smart city architecture. In the smart city, the various sensors throughout the cities are connected by the IoT network and put into the big data repositories, and then analyzed and making the decisions and used to improve the quality of various verticals. So as a total, it makes the IoT-enabled smart city. In the sense of the business model, actually, this one is the most challenging, the model. It's not that easy to make the sustainable business model based on this idea. So it's a big challenge, but we feel it is the real benefit to society. So NEC as a company, as I introduced at the beginning, we decided to focus to create the social value. And for NEC, urban IoT is the IoT we will work with. Frankly, most of you, including NEC, and most of you are not really invited in the game of industry IoT or consumer IoT. Industry IoT is driven by the manufacturers, and the consumer IoT is driven by the brands like Nike or others. So most of the enterprise and most of the government, the IoT should mean the urban IoT. I'd like to introduce the couple early stage the IoT examples or use case. This is what we are offering the video surveillance service in Argentina. In this case, we are not selling the video camera. We are not selling the software. We are offering the video surveillance as a service. And then we use the image analysis, the software, inside of our service, such as detecting the number plate, the reading the number plate, or the detecting the unattended objects, or some strange behavior of the crowd. So we use our own technology to improve our own service. Second use case is the waste management. This is we deployed in Spain, in one of the small cities in Spain. In this case, it may be hard to tell that we attach the little sensor on the back of the lid of garbage bin to monitor the amount of the garbage accumulating inside the garbage bins. And based on those informations, we optimize the routing of the vehicles. And we also attach the mechanism to invite the citizens to participate in these activities. Using the smartphone, they can easily report the unattended garbage or some abnormal conditions. The third use case is the agriculture. In this case, the different type of sensors throughout the field, monitoring the weather conditions or the condition of the soil, and also the other field data. And all of those data is gathered to a single locations and analyzed to improve the harvest. So those are the cases the NEC act as a solution provider, so that we provide all of these as a service. But whenever we offer the service, there is the challenge. There is a technology involved on the backside. That technology includes actually the all aspect of the ICT, namely the networking or the computing, including the storage, or the data science. Because of the limitation of the time, I will focus on the data science today, but I briefly touch upon the network aspect in 2 pages. It's very hard to see on the screen, but what it says in the IoT environment, that depending on the type of applications and the type of sensors you use in your solutions, the network requirement, the performance requirement is quite different. Some application, like the video surveillance, requires the high bandwidth. Some application, like transportation management, requires the very low, it allows very low latency. In other applications, like agriculture, need to support the massive number of devices. So those extreme requirements in the different aspect, it is rather difficult to support all of them at once by single network. In many cases, the mobile network can support the IoT application, but not in the optimized way. So our proposal is to build the IoT specific network. It shows the very rough conceptual pictures. It could be a sort of MVNO. We could share some of the infrastructure with the existing commercial network, but we feel there is a good reasons to have a separate network for IoT applications. In the sense of the resource optimizations, or just to add the innovative tariff, rather than the data size-based, the packet, the billings. And another important point is the data processing inside the network. Yeah, cloud computing is powerful, but it may not be the best way to send all the data, all the raw data, to cloud locations. It might consume too much bandwidth in the network. So this is what we call the edge computing. There's some data processing in between the sensors and the cloud. By adding these functionalities, we could make this network as a smart pipe rather than a dumb pipe just to offer the connectivities. This network could be a smart pipe. Okay, so maybe I can borrow another statement by the previous speaker. We recommend to apply the SDN, software-defined networking technology, to build this IoT specific network. It makes a very good sense to virtualize the network because you cannot tell how fast it will grow, or we could mix the different type of network based on the optimized for different parameters virtually on top of the single physical network. So it is the very good combination of the virtualization of network and IoT specific network. So the last 5 minutes, I will talk about the analytics, the big data part. It shows our unique engines developed in-house. The bottom three are more related with based on the biometrics identification technologies, and top two are more for the data analysis. I will touch upon the biometric technology first, and then the analysis. NEC is known as an expert of the biometrics authentications. They're starting from the fingerprint, and nowadays the face recognitions. And we could use these face recognition technologies in these IoT solutions. In addition, for more society or the social solution focus is the detection of the behavior of cloud, this time the group of people, how they behave as a group. By detecting or knowing their behavior in the real-time basis, it could be a very good information to optimize the transport management or logistics or the emergency response. So those information can be a big the help, once again, to improve our social solutions. Our face recognition technology is listed as a #1 technology in the area of the accuracy and as well as the speed to identify a particular person, either a black list or white list or the one-to-one judgment. Okay, so whoever wants to harvest the big data and wants to analyze the data and get the new insight out of the analysis needs to have the resource of data scientist and the domain expert. And those two are very hard to get these days. One of the solutions we offer is to use the machine learning. It could be called as artificial intelligence. Once I call that way, it may sound scary, but we have the two unique machine learning engines, which we call the invariant analysis and heterogeneous mixture learning. So I'd like to very briefly introduce those two technologies. Invariant analysis is to detect, to learn by itself. It's a machine learning. To learn the normal condition out of so many data from so many sensors. It is rather difficult to tell the individual person to tell if it is the abnormal condition by monitoring a single parameters. So that the software will detect the abnormal condition comparing the normal conditions, which also learn by itself. So there is no domain expert required, no data scientist required to define the normal condition and to detect the abnormal conditions. Something wrong? It can be applied in many different fields, but because of the nature of the technology, it is suitable to apply to the field with so many sensors. One of the early commercialization is done for a nuclear plant in Japan. So we monitor the over 3,000 sensors and once again, to learn the normal state and prepare to detect the abnormal conditions. Second technology is what we call the heterogeneous mixture learning. It is strange English even, but what it does, it will predict based on the parameters, different parameters. And in the past, we need to have a domain expert who has some knowledge. This particular parameter is more significant for this result, and they need to cut and try many times. But with this technology, with the certain learning period, it will the formula will be generated once again by this software itself, and it will apply that formula to predict what's going to happen in the future. And it can be applied to many different technology as well. The most typical application we propose is to use this technology to predict the energy demand or the water demand based on the different parameters, such as the weather conditions, the populations, events. And the first commercial use case is the automatic ordering system for the convenience store. Instead of depending on the hunch by the store manager, this software can be used to decide what needs to be ordered for next day's sales. Okay, this is the last view graph I'd like to share with you. And this is the last but not least, the security issues. Particularly the IoT or big data is applied to the social infrastructure systems. We don't want to see the traffic signal is hacked or other important infrastructure jeopardized. So to support this, the NEC has a variety of the cybersecurity activities. In addition to the physical security I mentioned, like biometrics, we do have the cybersecurity activities, which includes the training of the cybersecurity resource in the customers' organizations. And we could have the forensic laboratories or the cybersecurity as a service we could provide. So we feel the big data is already the big theme, but by combining with IoT, it even broadened the scope of the activities. And that there are a lot of interactions between the IoT, big data, cloud computings, and also the securities, the important issues. And we are here to support the social issues resolved. Thank you very much.